A comma B, return A plus B. And whenever you call sum
1
it will print the sum.
answer. Okay. Yeah.
So if I ask you like what is the what we call name
Type.
of this function, that is sum. Okay. What if the function doesn't have any name? What's that function called? If someone doesn't have name, what we call him? Anonymous.
Anonymous. Sorry.
Lambdas are anonymous functions.
Okay.
Function doesn't have any name. Okay. Like for example, if we can start lambda with keyword that is lambda. The variable we will pass and the result we will return.
Okay.
So whenever you call x like this, it will return.
Okay, so you can write the whole function in one line.
Correct. So this is lambda. So if we call lambda, then lambda will be like this. It will start with the keyword lambda. This will be the keyword. Okay. These are the parameters that you can pass. This can be n number of parameters. A single parameter will also work, but there should be a parameter. And this is the result you will return. Or we can more specifically
or the operation. Okay.
Business logic will be here. Okay.
No.
See, compare this and this function now. So forget about this keyword. Then parameters A and B. So this is the parameter B. And the result will be A plus B. So the result will be.
Okay.
Got it?
Yeah.
Now, when we will use lambda much? So before that, let me give you an example. Okay. Now, when will I call sum? We define it here. Sum 1 with 10. Okay.
Okay.
If you now print y, it will be 20. Okay. I will tell you. Okay. And if you check the type of y, it will be an int. Okay. So what it will do, we are doing in it here. We are calling another function from. Okay. So one more thing. In Python, what we can do, we can return a function from function.
Okay.
We can return a function from function. Okay. Let me tell you an example. Give me a minute.
Okay.
And what if I do like this? Sum2 A comma B. Inside that I define sum3 with B only. The result will be return B into 20. Now I'm out of this. Then what I will do, I will return sum3. Now if I do y is equals to sum2 with 8, 9, and if I print y, see, to check like this, it will be y. See what is the difference between these two? Give me a minute. Where was that? Yeah, this and this. What is the difference between these two? Can you observe?
We are calling two functions in the bottom one, and the first one only one function has been called. No. Yeah.
Okay. So see, in here, what we are doing is we are calling another function. Okay, we are not returning it. See, when you call this function, the 10 value will goes into this A.
A goes
Okay.
10. Yeah.
And this function is called. See, this function is called here. The same what you have done here, you have done the same thing here also. Correct. So it will call this function, the sum1, and it will be executed, and the value will be returned, and the value will be stored into this. Okay. But here what we have done is we have defined a function. In that we have defined another function, that is the nested function. And here I am not calling any function, but instead of that, I'm returning that function. Okay. But here I was calling that function here. Okay, I'm not returning that function. So when I call this sum2, the function will be returned and stored it here. Okay. Now what if like here I've checked the type of y, that was integer, because I have called this function and the value will be returned. Okay?
Yeah.
But here I haven't called any function. So the whole function is returned. See, the function is written when I printed. And when I've checked the type, the function was y. Now the thing is how to call it. Now if I do 8 here, like this, it will be 160. So first of all, you have called the sum2 function. Okay. And the result was a function. So you have called this again. Then you will get the result.
Okay.
Okay. Got it till here?
Yeah.
Now what if I do like this?
Deepak, 1 second. How do I know which function I have to call when you're writing?
You need, because see, this is the function. Let me open this for you. It will be like this. Okay, so this is the sum2 function. Okay, with a comma b. And inside it, we have defined another function, sum3.
Okay.
Okay. With a.
Yeah.
Now the thing is, you are here. Okay. So you only know sum2 function. You are not aware about sum3 function. Okay. Because the scope is up to sum2 only. Outside sum2, sum3 doesn't exist.
Okay.
If you call it like this, it says sum3 did not define. If you call it like this also, sum3 is not defined. So the scope is limited up to sum2 only. So when you are calling sum2, then sum3 will be revealed.
Okay. Oh, okay. Got it. Got it.
Got it?
Yeah.
Okay, fine. So this is like, you know. Now the thing is,
one more question, Deepak. Now, since we call sum2, right? But why did we give two parameters when we gave two parameters, we didn't get any answer. When we just passed it one parameter, then when we gave y of 8, we got the output. So that part.
Okay. So see, this was a demo purpose only. Okay. I haven't performed any operation on them. But the thing is, see, when you have you are having sum2. Okay. You called sum2. Now what sum2 has given you? Sum2 has given you this.
Okay.
Okay. Now it will be like outside here. Select it again. Let me some. So this will given you this. Okay.
Oh.
Now you need to call this function. Okay.
Okay.
It was a private function until here.
Okay.
But when you have called sum to the function, it has returned you the sum3. So now it is not private to you.
Okay, because of the return function. Okay, you're returning the value something. Got it.
Correct. So you will call it.
Okay. Yeah.
So that's why only one value will be used here.
Y of 8. Okay.
Now another thing is you have now the thing is what is lambda? We have talked about. Lambda was anonymous functions. Okay, so we can do it like this also. Okay, if you do like this, then if you do like this, then, and if you check type of z, that will be a function.
Yeah.
If you print z, then it will be a function, but of which type?
Lambda.
See, here the function is of which name?
Sum3.
See, read this whole expression. Function sum2. Okay, local sum3. It means sum3 will be a local function to sum2.
Part of sum2.
Yeah, and here we have written it. Okay. Now, see, sum2 locals lambda. It means that lambda will be a local function of sum2.
Okay.
Okay. And if you call it like this, then it will give the result.
Okay.
Got it?
Okay.
So this is how lambda is used.
Can I not say z of some number?
Pardon?
If I have to find an output, should I be doing all these steps like what is the type, or just give z of 8 only?
You can do it like this also. This is also.
Okay. Okay. Two functions.
Understood?
Yeah.
So this is where like lambda is used the most. Got it till here?
One more question. How are we getting answer to be 120?
See, when you call this line, it will return a lambda function. Okay.
Okay.
That is stored into z. Now you have called another function, lambda function. So function calling will be like this, but the function is stored into z. Okay. So you have called a function like this, and it will return the result. Same here. When you call sum, when you call it like this, z is equals to sum 10, 20. Sometimes. Okay. So what it has written? It
30.
has written no, it will not return 30.
Okay.
But it will return.
Oh, b into 20 part we would do.
It will return like this. Z is equals to sum 3 a, then return a into 20.
A into 20.
Like this.
Okay.
Go with the example. It will return like this. Okay. Now z can be represented by which thing? The sum 3. Okay. So now z means sum 3.
Okay.
Got it?
Yeah.
So till here, z is equal to sum 2. It means sum 2 will return a function sum 3. That sum 3 function will be stored into z. Now you are calling sum 3 function. So when you call sum 3, it will be like this. Sum 3 with 8. Okay. Since z has been replaced with sum 3, so you can call it like this. Okay. Same thing we have done. See, sum 2 is having a lambda expression. Lambda expression doesn't have any name. It will be a function without any name. So it will be an anonymous function. Okay. So that anonymous function has been stored into Z. Now you have called the function again. Okay. And here what I've done is, here I have called this. I haven't stored the result into something, but on continuous note, I have called this function again.
Yeah, one more thing. See over here, when I say sum2 is a comma b, it will be 10 comma 20 is what you're taking, right?
Correct.
A will be 10, b will be 20.
Correct.
Then how come the next b will take the value as 6? That part I didn't understand.
See, this will be a function only. Okay. I haven't used this value here in this function.
Okay.
Okay. It will be a different value. Okay. So see, if I'm having b like this, okay, a and b here, a comma b here, okay, and b a here, okay. So the scope of this a is up to sum 3 only. Okay. So outside sum 3, the a will be of this type. So they will be two different a's.
Okay.
So the value b here doesn't refers to this b. It is different b.
Okay.
Because it is local to the lambda function.
Lambda expression.
Got it?
Okay.
Got it till here?
Yeah. So what is the purpose of we doing it like this then?
It is a shortened operation only.
Okay.
It is a shortened operation. It doesn't need to define any space for it.
Okay.
Yes. And most of the times we will need it, because like defining these type of functions will not be a good thing, good programming skill. Like if you want something like to be returned into a single line, then you should go with the lambda expressions.
Okay. Got it.
Any doubt?
No. Need to study more. Yeah.
Yeah, you need to. Okay. Now the another thing, we will go with iterators. Lambda expressions are clear to you, correct?
Kind of.
Okay, so you will, like, whatever I have done, I've told you, just figure out some things and like write lambda expressions for them also. It will like, make you practice more.
Okay, got it.
Okay.
Yeah.
Now iterators. So what the name suggests to you?
Doing something continuously.
Continuously. Okay, got it. So we have gone through lists, okay, sets and tuples. List like 1, 2, 3, 4. And when you start iterating it, it will be for I in list. And I. Like this. So list is an iterator. Okay. Iterator means like list is an object which can be iterated. Correct?
Yeah.
So we can call it list as a iterable objects.
Okay.
List, tuples, sets are iterable objects. Okay. Got it?
Yeah.
Now the thing is, if this is the like iterable objects, we can iterate it using for loop. Then why iterator has come into a play?
Possibly it uses lesser memory space or something.
Okay. See, the thing is, if you are modifying, suppose this is you are iterating it. Okay. Let us go like this. You are iterating it. Okay. And instead of this, what you have done, list dot append. What we call I again here.
Yeah.
And then we are printing done. See? Well, stop now. So this is not good. Okay. because what we are doing is we are modifying the list again and again in the same thing.
Yeah.
So it is
We are
like
adding the same list back to the back of it again.
correct. So there are two terms, fail first and fail safe. So these are fail fast classes. Okay, it means like these are fail fast. It means like when you will append anything inside it, it will behave differently. Okay. So for that purpose, iterator has been used. Iterator is a fail-safe class.
Okay.
Okay. So when you use iterator, it will be. Let me type list it here once. The list has been changed, modified. Okay. Now what I will do, I will create this list again. Now, I have created this list. Okay. It's ITR. Now see, I will not iterate it. What I will do is ITR instead of calling it, I will call it just like this.
Oh.
See. So this is like iterator. You don't need a loop finally. So like counters you have gone through counters. Okay. If something is inserted, the counter should be like raised by 1. Okay. So for these purposes, the iterator has been introduced. Okay. So this isn't like whatever I've done. This was like auto created, like already created inbuilt iterator. Okay. So the benefit of the iterator is like if we call it like this, then it will be a iterator class. Okay. It will be having 2 functions. And this function. Okay. It was like an iterator only. So when I say counter, it means it will be raised by 1. Okay. I will start my counter from 1. To bind this, I will use self arrow. Okay. And when I will call this, it will start my iterator from here only. So I will return self dot. Now for next, when I will call next, the iterator should be increased by 1. And how it will be increased? Like whatever the value will be there, I will pass that value. I will return this. Okay. See, so when you will start the iterator, okay, the iterator will be started with this method, iter. See, here what I've done is I have used this method, iter method. When I will call this, so this value will be initialized by 1. Okay. Now when I call this function next, it will call this. The 1 will be returned to you, and it will be auto increment inside it.
Okay.
It will be incremented like this. So let's implement it. So like this iterator that we were talking about, it was created like this.
Okay.
Inside it, there were 2 functions, this one and this one. So this one will be the initialization function that will initialize all the things, and this will be the counter function that will count things, okay, and iterate things. Okay. Now see, here we have got an exception. Okay.
Okay.
But we have created this class. So let me first do this class. Let me save it. Okay, so what I will do is I will create one class that is known as counter. Inside it, I will define this
ITER
function with self as an argument. What I will do is I will initialize this with 1, okay, and I will return this.
self.
Okay, and after this I will create another that is known as next with self as an argument. Okay, what I will do is I will return this a value. Okay, I will increment it so that next time the value will be incremented
by 1,
and I will return x here. Okay, so this is the class, counter class. Okay, what I will do is now I will create an object. Okay, ITR counter, that will be the variable. See, I have used this function to initialize my counter, correct? Now what I will do is I will iterate it for okay. Give me a minute. Non-iterator. This is like an integer value, but I have to make it an iterator, so it will see. It is incrementing like. So I haven't break anything. I haven't used a break here. That was the purpose, because I will show you. So it is like the counter started from 1 and it has gone to like wherever we have stopped it, around 1700 and something.
Okay.
See, okay. It is fine. Clear till here? Now the thing is, see, we have use the already created inbuilt iterator here. Okay. And see, when the list length was like exhausted, the list was exhausted, it automatically stopped the iterations. Okay, so we need to do like this only. Okay, so we need to limit our counter. Okay, just count till here only, do not go away from that. So we need to define it. So how to do it? Like, first of all, we need to check if our self dot a should be less than equals to 30. Let's say. Okay. So only 30, up to 30 it should iterate. Okay.
Then you do the counter exercise.
Yeah. And whatever we will do that again. Okay. And we will return the x. Correct. What if it will like goes more than 30? So for that, what we will do is we will raise an exception. I will teach you after that about exception only. I will raise the exception. What is the exception? Stop iteration.
Okay.
Now let me run it. See.
Okay, got it.
So till 30 it stopped. Now see, if I haven't used this, okay, if I haven't used this, then it will not print anything. Okay, it will not return anything, but the program will not terminate. The program will go on because I haven't stopped the program. Okay.
Okay.
Tell here, clear?
Yeah.
Lambdas and iterators both are clear.
Kind of, yes.
So see, whatever we have done inside it, okay, these are known as generators. Okay, generators means like we are generating a value.
Okay.
If you do like this, instead of this, see.
Okay.
Generating a value here. Okay, so these are known as generators also.
Okay.
So generators on like base, they will use iterators inside it.
Okay.
Correct.
Okay.
Okay. Now we will go with another topic that is known as exception handling.
Okay.
See, we want to stop the program, so we have done this. What is this? So this is like an something interruption, like any interruption in the program that is caused by us. Okay, or not us. It will caused by anything. Anyone can raise this exception. So exceptions, there are two different kind of exceptions and errors. Exceptions are the, like we can say, agents that can stop the execution of a program for a while.
Okay.
If you handle them, then it will be fine for us. It will not. But if error occurs, it will completely ruin your program. You can't do anything with your program now. Like for example, if you have a list and you want to access the 10th element, but the list didn't have, so there will be out of range exception. Okay. Now, suppose if your hard disk crashed, okay, now you can't run your computer or you can't switch on your computer anymore. So that will be an error. If you handle that, okay, my list size should, whatever the value I will be accessing should be less than my list size. Then the exception will be handled. Okay, you will never get that exception again. But you can't handle that hard disk failure. It can be crashed anytime. So error are the things that can stop the execution of the program, but exceptions can interrupt your programs.
Okay.
So if someone is throwing an exception, like you have thrown something, so if you have thrown something on me, then I need to handle it. So how I will handle it? Either I will not, I will drop the thing. So it will be like another effects on the program, or if I catch those things. Okay. There can be two things. Either catch it or you can drop it. If you will drop it, then there will be severe effects. If you catch it, then it might be handled.
Okay.
So what we will do is exceptions you are aware, and whatever the exception thrown, we will handle those exceptions.
Okay.
Okay. So if you are saying, if I'm saying I will handle that exception, what does it mean? Handle the exception means I need to tackle that
Yeah.
So how to tackle? So there are some things like try, except, else, and final. So else will be a free substance with everything. Okay, we need to focus on try, except, and finally. Okay.
Yeah.
So try block is a block. It will be block. Okay. So it is a block where you write your logic. The program you want, you can write. More focusedly, the program that can cause exception. Adding two numbers. Okay. Adding two numbers never raise an exception. Okay. Either you can add 0, minus, negative numbers, positive numbers, infinity, anything you can add. It will never raise an exception. So why to write that code into try block? Okay, it will be waste. So in try block, we will write the code that will raise an exception, that can raise an exception, like touching a list, element in a list with a specific index. That can raise an exception if the index is out of the bound.
Out of block.
Okay.
Got it.
So in try block, we will write those code that can raise an exception. And if the exception has been raised, then the exception can be accepted. So this is the accept block. Okay. What this block will do, this block will handle the exception thrown. Raised. Okay. Clear till here?
Yeah.
Now the thing is, how else block will work here. So if no exception has been raised, then this block will be executed. And for finally block, whether an exception raised or not, this block will execute. Got it?
Kinda. Yeah.
Now let me write an example. Divide by 0, let's consider it like this. It will be an error.
Yes.
Okay. So what if error has been raised, then what I will do is I will accept this. And what I will do is will print error here. Okay. For exception, what I will do is I will print this exception.
Okay.
Okay. Now else I can write here. Okay. Else exception caused. Okay. And find like this. Inside finally. Okay. So these are the 4 blocks we will have. Now one more thing. There was another keyword that is known as raise. Okay. So we have already used this keyword. So this will use to deliberately raise an exception.
Okay.
If you want to deliberately raise an exception, then else block will be raise will be used. Spelling is wrong. Raise will be used. Okay. Now someone asks you like how it is possible. Can we have multiple except blocks? Yes, we can have multiple except blocks. But the thing is, like for example, out of bound. Okay. Now another one was exception as EX. Another one was except only. So see, when try block raises out of bound exception, it will go into if try block raise exception, then it will go into this. And if try block raise in generic thing, okay, generic means then an exception that can cause, that can have anything. Okay. Go into this. So why I have written like this? Because out of bound exception is a subclass of exception.
Okay.
That should be mentioned before.
Okay.
Exception is the topmost class, so it will be like mentioned out afterwards. Okay. If you put exception first, then this will be the first. So what will happen? Any exception raised will be caught into this.
EX.
It will not go in this block anytime. Okay. So it will not be useful. So it will give an error that you will not be reached till here. So why to use it?
Okay.
Okay. Now one question to you is, like we are having a try block. Any exception raised will be goes into this. Okay. Why to use finally block if it's like executing both when exception occurred or not?
Once you have solved that, you faced it and you have solved it, and that is when you come into finally.
Okay. So why is finally used? What is the uses of this finally?
To get your final output.
You can get from try also.
Just to find out whether an exception is raised and will your output be executed. Hello.
Do it. Why finally? Yeah.
Whether you came across an exception and was the program able to be executed?
Say.
Yeah.
You are breaking.
Am I breaking? Oh, I'm sorry. Am I audible now?
Breaking, yeah.
Okay. Can I rejoin?
I'm not able.